Hey guys, so we're on the last section of this chapter. We're going to talk about 12.1, which just focuses on tangent lines. So if you remember, tangent lines are like those hit and runs. So we're just going to look at different scenarios of hit and runs on circles. So there's three scenarios. We're going to talk about common tangents, tangent and radius, and then two tangents. So I'm going to have you write down a little bit of information for each of these categories. So common tangents are when one or more lines are tangent to two or more circles. So I'm going to have you draw a picture. So let's say we have two circles. And I want to know how many tangent lines I can draw that will be tangent to both of the circles at the same time. So there's a few different ways you could draw this. One that comes across my mind is if I were to have a hit and run at the top of this circle, and then it keeps going, and let's say it also does a hit and run on the top of the other circle. That would be one common tangent line. And I can draw others as well, but I'm just going to do one example for now. Let's talk about tangent and radius. So here's a rule. When a tangent line and a radius meet, they always make 90 degrees. So let's draw a picture as well. So let's say I have a circle. I'm going to draw the center of my circle. I'm going to draw a tangent. I'll just draw it at the bottom here. I'll draw the point of tangency, meaning that's where the hit and run's happening. And I'm also going to connect my center to that point of tangency because I'm going to make a radius. So if you guys ever see a tangent line and a radius, they're always going to make 90-degree angles. Okay, and the last scenario is just two tangents. I'm going to have you write down tangents that meet at an external point are equal. So if I have a circle, and we've drawn a few of these before. If I have a tangent that touches the top of the circle, let's say I also have another tangent touches the bottom of the circle, these lengths are going to be equal. So let's just do some examples using these three scenarios. All right. Example 1 says, assume that lines that appear to be tangent are tangent. O is the center of the circle. What is the value of x? So let me look for my tangent lines. Well, the only line that looks to be tangent is this bottom segment here. You'll notice that O is the center. And coming from the center, I do have a radius. I actually have a diameter drawn, but half of it is definitely a radius. So right away, if you guys ever see a tangent and a radius, what can we draw inside of the circle? A 90-degree angle. Now you'll notice you also have a triangle here, and one of the angles is x. That's what we're looking for. So if you just want to find that angle x, what are you guys going to do? You're going to add everything up to 180. So you can add up your 90 plus your 51. It's going to give you 141. And then you can just subtract from 180. So x will end up equaling 39 degrees. Take a look at example 2. Example 2 says, is segment ST tangent to circle R? And we need to explain why or why not. So let me look for ST. Okay, ST is this bottom segment here. it looks like it's tangent. It looks like it's just touching the circle at S, but we need to mathematically show if that's correct. So you'll also notice that you've been given a radius, RS. So again, what can you draw inside of this picture? You can definitely draw a right angle. So we have a right triangle. I'm just going to label everything I know about the right triangle. I know the radius, or the left-hand side, is 5. I know the bottom, which looks to be the tangent side, is 12. And I just need to talk about the hypotenuse. This 8 is not the entire hypotenuse. It's actually just up to here. So up to here is 8. We need to figure out the entire length of the hypotenuse to start the problem. So how do you think we can get that entire length? We are just missing this little piece here. Well, you'll notice that little piece that we're missing is really just another radius. So no matter where your radius is drawn, it's never going to change in the circle. So this radius is 5, and I can just add 5 plus 8, so I now know my entire hypotenuse is 13. So how does this help us figure out if ST is tangent? Well, what have we been doing lately with right triangles? We've been doing the Pythagorean theorem. So why don't we do Pythagorean theorem and see if our calculations make sense? So we can say, does 5 squared plus 12 squared equal 13 squared? So 5 squared will be 25. 12 squared would be 14. 13 squared is 169. And let's go ahead and add that up. 25 and 144 does give us 169. So since everything works out, this is a true right triangle. And yes, ST is tangent to circle R. So I'm going to have you guys try example 3 on your own, so feel free to pause the video. If not, just keep watching and we'll work on it together. So example 3 is also asking, is segment ST tangent to circle R? We're going to explain. So again, we have what looks to be a tangent segment and a radius. So if that is a tangent segment, we'll have a right angle here. So we have a right triangle. Just going to label what we know about it. We know this side is 12. We know this side is 16. We now just need to figure out this entire length of the hypotenuse. We know just up to here is 7, but we also know that this radius is going to be 12 because it's going to be the same as the other radius. So altogether, that entire length is 19. So let's go ahead and try the Pythagorean theorem and see if our calculations work with these numbers. So does 12 squared plus 16 squared equal 19 squared? So 12 squared is 144. 16 squared is 256. Does it equal 19 squared, which is 361? 144 plus 256 gives us 400, which is not equal to 361. So what does this tell us? It tells us no, ST is not tangent to circle R. All right, let's take a look at the next example. So it says, what is the value of x to the nearest 10? You kind of notice these are all the same ideas. And I should have added in that segments that appear to be tangent are tangent. Because when I look at my picture here, I definitely have what looks to be a tangent segment. I'm going to make it tangent. And then we have that radius. So whenever you have a radius in a tangent segment, you can draw that right angle. You'll notice, again, we have another right triangle. Let's just label everything that we have here. We know this bottom is 12. We know this is x. Again, we just got to figure out this entire hypotenuse. So we have something for both parts. We have an 8 and we have this x. So you put them together, what are we going to get? It's not 8x. It's going to be 8 plus x. So again, we're going to do Pythagorean theorem. Just be careful with your 8 plus x. So we're going to have 12 squared plus x squared. And we're going to equal it to this entire group squared. So 12 squared is 144. X squared is just x squared. And anytime you guys are squaring a group, it really just means multiply it by itself. And this is what we were practicing today in class. So 8 plus x times another 8 plus x is double distribution, which is just FOILing. So I'm just going to take turns. I'm going to do 8 times 8, which I know is 64. Then you can do 8 times x, which is 8x. Then we'll do x times 8, which is again 8x. And then x times x, which is x squared. Okay, so let's combine our like terms. We got 64, we got 16x, and then x squared. Technically, you would just subtract x squared from both sides. They're going to end up canceling out, which is nice. That's what we want to work with. And then from here, you're just solving for x. So we can subtract 64. 144 minus 64 will give you 80 equals 16x. And then divide, x will equal 5. All right, let's take a look at example 5. So example 5 is talking about common tangents. Tell how many common tangents the circles have and draw them. You'll notice that I have 3 different types of groups of circles here. The first group, the circles are not near each other. The second group, they're touching it at one spot, and see they're overlapping. Whenever your circles are separate, you're going to have the most common tangents. So I'm going to draw that first common tangent that I drew on the very first slide. Let's say I have a hit and run at the very top. Well, we can also draw another hit and run going down here towards the bottom. But that's not the only hit and runs I can draw. What about in between them? What if I drew a diagonal line going from one circle, so it hits here, continues and hits the other circle here, and then I got a last one. I can do another diagonal right in the middle. So let's say it's hitting here, running, hitting here, and running. So technically there are 4 ways. There are 4 common tangents to these 2 circles. All right, when you look at letter B, there's going to be less common tangents because my circles are closer to each other, so there's less space in between them. So again, I can draw that top tangent, hitting the tops of the circle. I can draw another one hitting the bottom of the circles. And then I can do one in the middle. What if there's just one straight line going right down the middle and it just grazes each of the circles at one point? That's going to end up being 3 common tangents. How many do you think are going to happen with letter C, the overlapping circles? If you guessed 2, you're correct. You got the top tangent, you've got that bottom tangent, and I have no space in between them, so I can't draw any lines in between. So just 2 common tangents. Okay, moving on, example 6. So we are going to solve for x. So if you look at what's going on, I've got a picture of a circle, circle C, and I have 2 external tangents that meet at this common point R. And if I want to solve for x, what do I know about those tangents? They're congruent. So what do you think we're going to do with the 28 and the 3x plus 4? We will just set them equal to each other. Okay, subtract 4 over, divide by 3, x is 8. If you want to double check your work, plug it back in. We know this is 28. When we plug 8 in for x, this should also be 28, which it will be 28. All right, last but not least, example 7. Again, we're going to solve for x. If you want, try this one on your own. So we know that we have 2 tangents because, as you guys can see, we have some radii drawn, and we've got the 90-degree angle, so that's definitely telling us these are tangents. So these tangents are going to be equal to each other. So we are going to set x squared equal to 9, and then just take the square root, x is 3. And again, if you want to plug in your answer just to verify, you will get 9 for both lengths. Okay, last problem. What is the perimeter of the polygon? So notice I have 2 shapes here. I have a 4-sided shape, and I have a circle. Which one is the polygon? The polygon is the 4-sided shape. A circle is not a polygon, because a polygon will not have any curves. It needs to have corners, it needs to have angles. So we're trying to figure out the perimeter of the 4-sided shape. Well, I definitely know this right here is 8, this right here is 7, this here is 3, and this here is 17, but I'm missing a lot of other pieces. So let's just focus on like one corner of the polygon. I'm going to focus over here at this corner. When I look at that corner, it's actually 2 tangents outside of that circle. So what do we know about the 2 tangents? Well, they're supposed to be equal. So if one side is 8 millimeters, the other one's also 8 millimeters. Let's look at the other corner. Again, I have 2 tangents. They're going to be congruent. So this is going to be 3 millimeters. You basically just continue this all the way around the polygon. So I've got more tangents here. So this is going to be 17 millimeters. And then last but not least, I'll just do this in green. I've got some more tangents. So that is going to be 7 millimeters. Now, perimeter means adding up all of the outer sides. So we're just going to add everything that we have. So let's just basically double everything. I got an 8 plus 8, a 3 plus 3, a 17 plus 17, and a 7 plus 7. So the perimeter is 70 millimeters. Okay, guys, let me know if you have any questions. We're going to start reviewing for your test, which is going to be Tuesday. Have a great night.